C++ templates are powerful, but also confusing. What if I told you there is a rule that makes broken templates just go away? No errors, no warnings, just clean overload resolution. It's called SFINAE, and if you want to write next level code, you need to know it. Hello everyone and welcome to today's video. In this episode, we are diving into a concept that's both powerful and a little mysterious in C++. SFINAE, which stands for Substitution Failure is not an error. It's a core idea in template metaprogramming. And if you've ever worked with complex templates or looked under the hood of type traits and overload resolution in C++, you've definitely been affected by it, even if you didn't realize it. Let's break it down step by step. SFINAE is a rule in the C++ language that affects how template instantiations work. It comes into play when you're writing templated functions or classes, and the compiler is trying to choose the correct overload or specialization based on the types you give it. The rule is simple but powerful. If substituting template parameters into a template results in an invalid type or expression, the compiler does not treat it as an error. It just removes that template from the candidate set. Let's say that again, but more simply. If you give the compiler a few template options and one doesn't make sense for the given types, it just silently throws that one out and looks at others. This lets you write templates that conditionally participate in overload resolution, only if the types you pass in make sense. Let's say you want to write a function that only accepts types that have a size method. You could do something like this. Here is what's going on. Decl type uses the comma operator to ensure that this substitution is only valid if container.size is a valid expression. If t does not have a size method, substitution fails. Thanks to SFINAE, the compiler doesn't generate an error. Instead, it just removes this function from the overload set. You can even pair this with a fallback version. Now, if you pass in a stud vector, it will use the templated version. If you pass in an int, you will get the fallback. This is incredibly useful in generic programming. Libraries like the C++ standard library and Boost use SFINAE heavily to enable things like this: conditional compilation of functions, type traits and concepts, overload resolution based on type properties, and enabling or disabling functions for specific types. Before C++20 introduced concepts, SFINAE was one of the only ways to create type-safe conditional templates. C++ also gives us tools to use SFINAE more formally. One of the most common is stud enable if. Here is an example. This function only participates in overload resolution if t is an integral type. You could also use enable if in the return type or even in a template parameter list. Starting with C++20, concepts give us a more readable and declarative way to do what SFINAE does. So instead of writing this, you can now write this. But under the hood, concepts are still closely related to the same mechanism that made SFINAE possible. SFINAE is like the foundation. Concepts are the polished user interface built on top. To wrap up, SFINAE is a technique that allows template functions or classes to be conditionally included in overload resolution, based on whether the types involved cause substitution errors. It's a cornerstone of modern C++ metaprogramming and generic libraries. Thanks for watching. If this helped clarify things for you, give the video a like, subscribe and check out the playlist on the screen. See you in the next one.